Hello, and for this video we're going to look at some grade 8, grade 9 questions, recurring decimal questions that hopefully once we go through them it will help you get a better understanding, help you aim for those top grades. If you're still not quite getting them, maybe have a look at my previous videos where I go more into depth on how to solve them, as this video will be more just how me tackling the questions, giving a brief explanation as I do it to give more of a directive on the steps that you should be doing. These questions come from Maths Genie and Corbett Maths, and I've picked sort of I think 5 questions which I sort of thought were the hardest ones. So yeah, let's get right into it. So for the first one, for x equals 3.594 recurring. So again, like previous questions, I would make sure that the factor I times this by 10, that it lines up again with 594 as the decimal. So that's going to be 1000x, as I need to times this by 1000 to get back to that same repetition. So it's going to be 3594.594. Then we take those away. 1000x minus x is 999x. 3594.594, take away 3.594, it's going to be 3591. As that, take away that is going to be 0, then 4 take away 3 is 1, so 3594. So x, rearranging it, making x the subject, 3591 over 999, and then simplifying that down, I believe we get to 133 over 37. I wouldn't worry too much about, obviously simplify it if you can simplify it, but for this question it would probably be a calculated question, so when it comes to simplifying it, once you got to this part, 3591 over 999, you can get to the simplified part. If it's not, then you just need to be thinking about, will they be the same times tables, and then simplify it down from there. So that is the answer for our first question. Okay, so we're getting a recurring decimal times a recurring decimal. And what it wants to do for these questions, whether it's divide or add or subtract recurring decimals, because it's recurring decimal, we still do the same thing. We want to make it a fraction. And once we get the fraction, obviously, hopefully we all know how to multiply fractions. So, the 0.54 recurring, let's start there. Again, same thing, I want to make sure the factor of 10 I times it by has the 54 as its decimal, so it can be times by 100. So 54.54. If I times it by 10, it would be 5.454545, which doesn't line up, does it? And I then need to take it away to make it 0. So then taking away, 100x take away x is 99. 54 take away 0, 54. So x is 54 over 0. Sorry, 54 over 99, which we can simplify down to, they're both divisible by 3, and then that is 27. 27? No, sorry, 17. 18 even. And then that can also simplify again. 11, and then 6. So 6/11ths. And for the 0.5, I'm going to write x equals 0.5 again, just because, you know, it's just what we're used to. So it makes it a bit simpler. If you're being pedantic, maybe you should write y equals, just because you've already used the x, but you're not using the x in your final answer, so it doesn't really matter. It's just it's your working out, right? You can write whatever you want in your working out if it helps you get to the answer. So I'm just going to leave it as x. So 10x equals 5.5. So 9x equals 5. X is 5 over 9. So then we get our recurring decimals in fractions, so now we can multiply them. So 6/11 times 5 over 9 equals 30 over 99. Rewrite it here, 30 over 99 is equal to 10 over 33. And we can't simplify that any further, so that is our final answer. Again, same thing here, we've got two recurring decimals, so we want to make them fractions so we can then divide them. So 0.07, x equals 0.07 recurring. And again, because this 0 isn't recurring, look at my previous video, we want to line it up. So times it by 10 is going to be 0.7 recurring, which doesn't line up with this previous one. But with 100x, we get 7.7 recurring, which does line up, so it works. So 100x take away 10x, 90x, 7 take away 0, 7. So x equals 7 over 90. And then the 0.185, same steps as before. 185 all recurring, so that means it's 1000x equals, God, that was awful. My apologies. 185.185 recurring. Okay, so then take 1000x, take away x, 999x. 185 take away 0, 185. So x equals 185 over 999. And that can simplify to, I think they're both in the 27 times table. I know 185 is. 27 goes 185 5 times. And 27 squared is a 999 actually. We can do that. So 5 over 27 it simplifies to. So then we have our two fractions. We can put it back using the operator. So we get 7 over 90. Be careful of the order because obviously it's divide. So 7 over 90 divided by 5 over 27. 7 times 27 is our operator. And then 90 times 5, 450. And then that was, what is that going to be? 27 times 7, 189. Which then simplifies down to 21 over 50. As you can divide them both by 9. And that is our final answer for that question. Hopefully that all makes a bit of sense. So yeah, with these questions where you could even add them or subtract them, just convert them into fractions, and then it's just a basic, primary level question, adding and subtracting fractions. Okay, next question. So this time we've got a bit of laws of indices. So this is where these questions get a little bit harder because it's bringing in multiple topics. So we need to know the laws of indices. I know a negative indice means that it is 1 over. Then the power, 3 squared. So 1 over 3 squared is 1 over 9. Sorry, let me just make that a bit clearer. 3 to the power of minus 2 is 1 over 3 squared, which is 1 over 9. That is our first one. So then, again, change the recurring decimal into a fraction. 270 is all recurring, so we're going to be times it by 1000x, aren't we? Once again, we need to line it up so that we can subtract it to make a nice whole integer. So 999x equals 270. X equals 270 over 990, which is 30 over 111, I believe, which is then, divide that by 3, 10 over 37. So we have 1 over 9, divide 10 over 37. 1 times 37 is our numerator. 9 times 10 is our denominator. And then that is our final answer, as we cannot simplify that any further. Always simplify your answers. I mean, it's got it in this question, simplest form. But even if it doesn't say it, just simplify your answers, always. Okay, and for the last question, I liked this question as it requires you to really understand the topic. So if we look here, so 0x is recurring. So I'm just going to write it out, as I said before in the previous video. Just write it out if you're not sure, so you can visualize what this recurring thing actually looks like. And it says that x is an integer such that 1 is less than or equal to x, less than or equal to 9. So that means it could be 0, 2, 0, 2, 0, 2, 0, 8, 0, 8, 0, 8, 0, 9, and so on, right? It's going to be something. Doesn't really matter. Doesn't impact our question. And what we'd usually do is we'd say our recurring decimal is equal to x. But the problem here is that we've already used x, so it doesn't really make sense to use x again. It would just make things a bit complicated. So instead, I'm going to use y, could use a, could use b, could use a square, could use a star, could use an avocado, you know, it doesn't matter. So we've got y equals 0.0x recurring. So we just follow the same steps we usually do. So I'm going to write it out again here. So we have this. And again, so we want to times y by a factor of 10 so that the recurring, these decimals then line up, so then we can take it away so that we get a nice whole integer to then make it a fraction, because we can't have decimals in our fraction, right? So if we times it by 10, so just for the sake of this question, we'd get 0.x, and then it'd be 0x, 0x, which does not line up with the original one, right? If we then took these away, we'd get 9y equals, well, it's not going to be, it's going to be 0. Something. It's not going to be 0.0, which is what we want. We want something 0.0. So let's times it by 10 again. So times the original by 100. So times that by 100 gives us x 0.0x. And there we have it. These two here then match up. We have what we want. So if we take these away, so 100y, take away y, that's 99y. X 0.0x, take away 0.0x, it's just going to be x. And then just a simple bit of rearranging, making y the subject, y is equal to x over 99. And if we look what it wanted to prove that 0.0x recurring is equal to x over 99. And there we have it. Again, in the mark scheme, it might probably uses y, pretty sure it does, but again, you could have had a equals x over 99. What you couldn't have is x equals x over 99. They might give you the marks anyway, but it's just a little bit confusing, especially if x is here, you know, you'd be rearranging. You have 99x equals x, which you can't have, right? It's a bit of a paradox. So yeah, that was all those questions. If you understand all that, if that made a lot of sense to you, then congratulations, you've completed this topic. Don't worry about it. Do a few more questions, obviously. I will link the Corbett Maths and Maths Genie worksheets that I pulled these from. Complete a few more of the questions from there, and you should be all good. Hopefully that all makes sense and my explanations are okay. If it wasn't, maybe have a look at the previous video, so that, because I skimmed over a lot of it here, just because I assumed you watched the previous video. But yeah, hopefully those explanations were okay. Yeah, that is all. Thanks for watching. Cheers.